Hey guys, in this video we're going to talk about Chapter 12, Section 4, Linear Functions. So recall that when we have one variable as an input, a linear function is a line. And it can be written in the form y equals mx plus b, where m is the slope, and b is our y-intercept, so where it crosses that y-axis. Now, you need 2 points to define a line, right? Because if you only have 1 point in the plane, let's say you have a point maybe right here, well, you can draw infinitely many lines through this point, right? You can draw a line like this, or you can draw a line like this, and there's many, many, many more lines that you can draw like this. So you need 2 points to define a distinct line. Now we're going to talk about the 3-dimensional analog of this case. So in 2 variables, it turns out that a linear function is a plane, okay? And so a linear function is a plane, and it has this form z equals mx plus ny plus c. And in this case, m is going to be the slope in the x direction. And n is going to be the slope in the y direction. And finally, c is going to be our z-intercept, or where the plane crosses the z-axis. Okay, so unlike a line in 2D space, in 3D we need 3 points to define a plane, okay? And we need all the points to not be collinear, aka not all on the same line. So as an exercise, I'd like you guys to think about why this statement is true. Why do we need 3 points to define a plane rather than 2 or 1? And why can they not all be collinear? So I'd like you to think about that. Hey guys, in this video we're going to talk about Chapter 12, Section 4, Linear Functions. So when our input was in one variable, a linear function was a graph that was a line. And we could write our line in the form y equals mx plus b, where m is the slope and b is our y-intercept. And we need 2 points to define a line on the plane, right? Because if we were only given 1 point, such as a point right here, we could draw infinitely many lines to this point that would be valid, right? We could draw a line like this. We could draw a line like this through that point, a line like this perhaps. So we need 2 points to define a line on the plane. So what we're going to talk about next is the 3D analog to the idea of a linear function. Now, when the input is in 2 variables, a linear function's graph is a plane. And a plane can be written in the form z equals mx plus ny plus c. That's one way to look at the plane. And in our case, m is going to be the slope in the x direction. Right, we're going to have 2 different slopes of the plane here, depending on how we're looking at it. And then n, this guy in front of n, this is going to be the slope in the y direction. Okay? And instead of needing 2 points to define a plane, just like in the in the one variable case, we actually need 3 points to define a plane. And not all the points can be collinear for this to happen, so they can't all lie on the same line. So you can't have 3 points that lie on a straight line like this and define a plane. And it's a good exercise for you guys to think about why this statement is true. So why is it that we need 3 points to define a line? Why is it that we need 3 points to define a plane and not 2? Alright, so let's just jump right into the examples. We want to find a formula for the linear function whose graph is a plane passing through the point 1, 2, negative 3, has a slope in the x direction and a slope of 2 in the x direction and a slope of negative 5 in the y direction. So our basic form is going to be z equals mx plus ny plus c. And based on what we're given a point that the plane passes through, and so I know for sure that we have an x value of 1, a y value of 2, and a z value of negative 3. And we also know that we have a slope of 2 in the x direction. So m is going to be 2, and we also have a slope of negative 5 in the y direction. So n is going to be negative 5. And now we need to figure out what this constant c is so that we can write the equation. And to do that, we can just plug in all of these values into this equation and solve for c. So let's go ahead and do that. So we have negative 3 equals m times x plus negative 5 times 2 plus c. Alright, so simplifying this out, we get 2 negative 10 plus c. So we have negative 3 equals negative 8 plus c. Add 8 to both sides, and we get that c is equal to 5. Alright, so now that we have that, we can replace m, n, and c and leave our x, y, z variables alone so that we can create a function. And our function is going to be z equals m x plus n times y plus c. So this is our linear function right here. It passes through the point 1 to negative 3. It has a slope of 2 in the x direction and a slope of negative 5 in the y direction. Alright, let's do another example. A plane cuts the z-axis at z equals 5, and it has a slope of 2 in the x direction and a slope of negative 1 in the y direction. What's the equation of the plane? Alright, so we're given some information here. Well, first of all, we know that a plane cuts the z-axis at z equals 5 and has a slope 2 in the x direction and a slope negative 1 in the y direction. So for sure, we know that the slope in the x direction is 2, and the slope in the y direction is negative 1. Okay. So, what else do we know here? Well, let's see. So, if the plane cuts the z-axis at z equals 5, it's going to look something like this. Okay, so there's our... So it's gonna cut this z-axis right here. And this is going to be at z equals 5. So if it touches the z-axis at z equals 5, what does that tell us about our x and our y values? Well, they have to be 0, right? In order for this thing to intersect the z-axis, the x and the y values have to be 0. So we have x is 0, y is 0, and z is 5. And if we plug all of this stuff into our basic equation, z equals mx plus ny plus c, we get 5 equals 2 times 0 plus negative 1 times 0 plus c. Solve for c, and we get c is equal to 5. Alright, so our equation is going to be z equals mx minus 1 times y plus 5. And this is going to be our equation. So it's going to cut the z-axis at z equals 5. It's going to have a slope of 2 in the x direction and a slope of negative 1 in the y direction. So let's take a look at what that looks like in GeoGebra. Let's put this guy in GeoGebra and check it out. So we have z equals 2x minus 5 plus 5. Minus y plus 5. Alright, so we have this guy right here, and we can see if we rotate it, it does indeed cut the z-axis, that blue axis at z equals 5. We can see that. And it has a slope of 2 in the x direction. So what that means is that if we were to rotate this guy so that we're in the xz plane, you see we're just ignoring the y-axis, we're ignoring the green axis, this thing is going to have a slope of 2, right? These sides are going to have a slope of 2. On the other hand, if we check out this guy in the perspective of the yz plane, let's do that. Let's put our y-axis horizontally and our z-axis is vertically. So now it's telling us that in this perspective, the slope is actually going to have, the slope is actually going to be -1. All right, if we're looking in the y direction, we have a slope of -1. If we're looking in the x direction, we have a slope of +2. If we look in the y direction, we have a slope of -1. Okay, let's go ahead and look at another example. Find the equation of the plane passing through these 3 points. So we do need 3 points to define a plane. And we're not really told anything about the slopes here. You know, if you graph these points, you might be able to figure out something, but I like to solve this without using the slopes at first. And we can, because we have 3 points, and what that corresponds to is 3 equations, and we're going to have 3 unknowns. All right, so remember what we're trying to do is find an equation in the form z equals mx plus ny plus c, and we don't know about c, m, or n, but we definitely know some things about x, y, and z. So the first equation I'm going to write is going to have to do with x is 1, y is 0, and z is 1. I'm just going to sub those into this equation right here. So we have 1 for z equals m times 1 for x plus n times 0 for y plus c. And so this clears to 0, and this just becomes 1 equals m plus c. All right, so let's go ahead and rewrite that right here. Okay, so that's equation 1. So we can do the same thing with the second equation. We can use the second point right here. X is 1, y is -1, and z is 3. So we have z is equal to m times x plus n times y plus c. All right. And so this is just 3 equals m minus n plus c. So I'm going to rewrite that. Okay, and finally we have one more equation to work with. 3, 0, -1. So 3 is x, y is 0, and z is -1. And so our equation is going to be just plugging everything in here. We get -1 equals m times 3 plus n times 0 plus c. This clears to 0, and I'm just left with -1 equals 3m plus c. All right, so we have -1 equals 3m plus c. And this is a solvable system. We have a system of 3 equations, and we have 3 unknowns. We have m, n, and c, and so this is definitely solvable. So let's go ahead and solve this. Figure out what these variables are. So the first thing I notice is that equation 1 and equation 3 both involve only m's and c's. So I'm going to take equation 1 and I'm going to isolate c by subtracting m from both sides to get c equals 1 minus m. And since c equals 1 minus m, I can just plug that in right here to turn this into a 1 variable equation. So I'm going to do that right now. I have negative 1 equals 3m plus, instead of c, I just found out what c was from equation 1. C is the same thing as 1 minus m. So now I can solve this equation for m. I get negative 1 equals 3m plus 1 minus m, and I get negative 1 equals 2m plus 1. Subtract 1 on both sides to get negative 2 equals 2m, and divide both sides by 2 to get m equals negative 1. Perfect. So the slope in the x direction is negative 1. So therefore, these 3 dots, m is equal to negative 1. Excellent. Now we can easily find c with that information. So, like, we can find a number for c. So because I know that m is equal to negative 1, I can just plug that in here to see what c is. So c is going to be 1 minus a negative 1. 1 plus 1 is 2. So therefore, c is equal to 2. And finally, we have n to worry about. Now the only equation that n shows up in is equation 2. So I'll just plug everything in. 3 equals m, which was negative 1, minus n, which we don't know, plus c, which was 2. Let's go ahead and solve for n. So we have 3 equals negative n and a positive 1. Subtract 1 on both sides to get 2 equals negative n. Divide both sides by negative 1. N equals negative 2. And so now we can write our equation with these 3 things. Our equation is going to be z equals m times x plus ny plus c. And this is our answer right here. Alright, let's try this one. Find the linear function whose graph is the plane through these 3 points. So again, we can do a similar strategy that we did before. We have this basic equation, z is equal to mx plus ny plus c. And we have some x, y's, and z's. So we have 3 equations. Our first equation I'll use with this point right here. So I have z is equal to m times x plus n times y plus c. Now this goes away to 0, and I'm just left with 0 equals 4m plus c. Let me rewrite that. Okay, so that's our first equation. Our second equation, we have z is 0 equals m times x, which is 0, plus n times y, which is 3, plus c. So this clears, and we're just left with 0 equals 3 times n plus c. Okay, so that was this point that we just did. And finally, the last point, we have 0, 0, 2, so we have z equals m times x plus n times y plus c. And this is actually really nice. This is nicer than the first one that we did, because these both clear to 0, and we're just left with c equals 2. Therefore, c equals 2. And now that we have c, this is easy, because this equation becomes 4m plus 2 equals 0. Solve for m. Okay, so m is negative a half. And then over here, if we solve for n, we get 3n plus 2 equals 0. 3n equals negative 2, and therefore n is equal to negative 2/3. Okay, so using m, n, and c, our equation of the line is going to be z equals m x minus 2/3 y plus 2. So this is our linear function. This is a plane in 3 dimensions. The slope in the x direction is negative 1/2. The slope in the y direction is negative 2/3. And our c value is 2. Find an equation for the linear function whose graph intersects the xz plane in the line z equals 2x plus 1, and it intersects the yz plane in the line z equals 8y plus 1. Okay, so let's just do a quick sketch of the line in the xz plane that the plane intersects. So the quick sketch, we have the z axis vertical and we have the x-axis horizontal, so this is the xz plane. And we have a y-intercept of 1, right? And we have a slope of 2. So rise 2 over 1, looks something like this, good enough, right? So this is z equals 1. And so when the plane intersects the line, it's going to intersect the whole line, right? If it would have said, you know, it's going to intersect in a point if it only hits in one spot. But the plane is infinitely, it's long in both directions, infinitely long in both directions, as well as this line. So, with that being said, that's our little sketch for the line in the xz plane. Now, what about the line in the yz plane? So we have something like this. So we have our z-axis again, and we have, of course, our y-axis is horizontal this time, and the line is 8y plus 1. So again, this guy is intersecting the z-axis at 1, and this time it's going to have a little bit of a steeper slope. It's going to have a slope of 8. Okay, so maybe it looks something like this. So this is the line 8y plus 1. And this is the line z equals 2x plus 1. Okay, so the plane is going to hit both of these lines. It's going to intersect both of these lines. And so what do we know? Well, from the xz plane, we can see what the slope of this line is in the x direction. The slope is going to be 2. So that's telling us that our m is going to be 2. On the other hand, in the y direction, the slope is going to be 8. So we have n is equal to 8. Now what about c? Well, c occurs when both x and y are 0, right? Because what we have is z equals mx plus ny plus c. And if I set x equals 0, and if I set y equals 0, I get z equals c, okay? And we can see that this value has to be 1, right? Because at this point, x is equal to 0, and we get 1 for z. And at this point right here, y is equal to 0, and we get 1 for z. Okay, so both x and y are 0, and z is 1. So that means that that z is 1 when x and y are 0, and so we have 1 equals c. So c is 1, and so our equation is just going to be z equals mx plus 8y plus 1. Right, so that is our equation of the plane that intersects the line 2x plus 1 in the xz plane and the line 8y plus 1 in the yz plane. Below is a partial table of values for a linear function. Fill in the blank, then find the function. Okay, so linear means that as x is increasing or decreasing by a certain amount, so is z. And also, as y is increasing or decreasing by a certain amount, so is z. So we have this table, this x/y looking thing. And you can think of x as being the numbers in this first column. So we have 2, 3 for x, and for y, we have these numbers in our first row. Okay, and then everything else in black are the z values. So, so we need to figure out what the pattern is. So what's happening to z as x increases, and what's happening to z as y increases. So for x, we have as x increases by 1, right? Because we're going from 2 to 3. So as x increases by 1, what's happening to the z values? Well, the z values here in this column are decreasing by 1, right? We're going from 0.5 to negative 0.5, so we're decreasing by 1 here. So as x increases by 1, z decreases by 1. Okay, so that's what we notice with x. And what about the relationship between y and z? Well, what we can see on the rows is as y increases by, this time it's actually increasing by 0.5 if we go from 1.5 to 2, then the corresponding z values are increasing by 1, right? We're going from 1.5 to 2 in the y's, and then in a similar way, we're going from 0.5 to 1.5 in the z's. Okay, so as y increases by 0.5, z decreases. Oh, I'm sorry, not decreases, I meant increases by 1. Okay, so knowing this fact, we can fill in this question mark right here. We can look along the columns or the rows, it doesn't matter. But if we're looking along the columns, we want to use our x rule. So as x increases by 1, so as we're going from 2 to 3, z is going to decrease by 1. So we have to subtract 1 from 1.5 to get the question mark, which is going to be 0.5. So our answer is, question mark is going to be 0.5. And now we can come up with a function. So the slope in the x direction is going to be the change in z over the change in x, right? Remember in Algebra 2 or college algebra, whenever you last saw this, when we think of slope in 2 dimensions, we think of change in y over change in x. But since we're in 3 dimensions, our output is z. So now we're concerned with the change in z over the change in the input. Okay, so our slope m, so the change in z, we can really, pick either of the columns, but if we pick this guy right here, well, the change in z is going to be the first z minus the second z, and that's going to be over the change in x. And the x that corresponds to the 0.5 was 2. Subtract the x that corresponds to the negative 0.5, which is 3. So we can simplify this out, and we get 1 over negative 1, which equals negative 1. So that is the slope in the x direction, is negative 1. Alright, so we can do the same thing for the y. So for y, our variable for the slope is n, and we're looking at the change in z over the change in y this time. Okay? Change in output over change in input is slope. We have 2 inputs, so we need to find 2 slopes. So again, now we're looking in terms of rows. Okay, so I can look at this first row if I want to, and I can say, okay, well, the change in z, we're going from 0.5 minus 1.5, over the y's that correspond. So 1.5 minus 2. Change in z over change in y. Let's go ahead and simplify this out. And we get negative 1 over negative 0.5, which is going to just give us positive 2. Alright. So now we need to figure out what c is, right? Because the whole thing is that we're trying to write a function. And our function is going to be of the form z equals mx plus ny plus c. We don't know what c is, but we sure do know what m and n are, and we do know some points just from the table. You can pick whatever point you want, x comma y comma z. I'm going to choose to pick x is equal to 2. And the corresponding y I'm going to pick to be 1.5. And the corresponding z is 0.5, okay? So that is that. I know what m and n are, so I'm going to use all of these things, plug them into each value to solve for c. Let's go ahead and do that. So we have 0.5 equals negative 1 times 2 plus 2 times 1.5 plus c. Alright, so we have c is equal to negative 1/2, and we know what m and n are, so we are good to go here. So our equation is going to be z is equal to m, which we found was negative 1, times x plus n times y, and finally plus c. So this is our equation that represents this linear table. Alright, let's look at a real-world example. So this example came out of your textbook. It says to avoid flying planes with empty seats, airlines sell some tickets at full price and some at a discount. The table below shows an airline's revenue in dollars from tickets sold on a particular route as a function of the number of full-price tickets sold, F, and the number of discount tickets sold, D. Okay, so I used D in the column, as you can see in green, and I used my full price tickets, F, in the column, in the first row, which is orange. So we want to write a linear function that represents the table above. And so what we are trying to do is we're trying to find the slope in the x direction or the slope in the column direction, and we're trying to find the slope in the row direction. And we have plenty of points to work with to find our missing variable c. So let's first figure out what the following is. Let's look at, and so our output is the revenue. So I'm going to just say that that's going to be R instead of Z. So we have the change in revenue. D. I don't like that. Okay, well, how about we just call it MD? Okay. So we're going to do the change in revenue. Which is basically everything that's not in the green or the red or the orange boxes. So all the black is the outputs. Okay. So this is going to be the change in revenue over the change in discount tickets. We're like treating this like it's our x variable. So what we can see along the columns, we can see that these values are changing by a uniform amount, right? They're changing by, looks like 40,000, right? So they're increasing by 40,000 as we go along the columns. And that goes for these columns as well. And these columns and these columns. We're increasing by 40,000 each time we move down the column. So, the change in revenue, well, we can say, you know, we can just look at these first two points right here. We can say the change in revenue, we have 85,000 minus 125,000, and then the corresponding discount numbers that go with that are right here, over 200 minus 400. Alright, so let's go ahead and compute this. So 85,000 minus 125,000. So this is going to give us negative 40,000 over negative 200. And what we're going to get is 200. So the slope in the D direction is going to be 200. Okay, let's go ahead and find the slope in the F direction. So we're looking at rows now instead of columns. So it looks like we're increasing by a uniform amount of 100 tickets, right? And so what's happening to my Z values? Well, those are all increasing by a uniform amount as well. And that's going to be by $45,000, okay? So if we want to put this in our slope formula, we have MF is equal to the change in revenue. Change in revenue. We're going to divide all of that by the change in the full price tickets. Okay, so yeah, so if we just look at like this first one right here, change in revenue, we're going 85,000 minus 130,000. And that's going to be divided by the corresponding row. So we have 100 minus 200. Let's go ahead and compute this guy out. So we have negative 45,000 as we expected over negative 100. And so this is going to give us 450. All right. Okay, so far what we have is we have the following. We have our revenue standing in place of Z equals MD, which is 200. And our D comes along with it just like our X would. Plus 450F plus C, which we're not sure what C is quite yet. But we do have several points that we can use to figure out what C is. I'm just going to use the point D equals, let's see, what's an easy point to use? How about D equals 200, F equals 100, and R equals 85,000. Okay, so we can use all of this to figure out what C is. Alright, so we have 85,000 equals 200 times 200 plus 450 times 100 plus C. Let's go ahead and compute this out. Okay, so subtracting 85,000, we get C is equal to 0. Alright, so our equation is going to be R equals MD, which is 200, D plus MF times F plus C, which is just 0. So this is actually our answer right here. Alright, so let's bring back what we just learned about planes or linear functions in 3D to our contour diagrams. Okay, so it says find a possible equation for a linear function with the given contour diagram. Alright, so keep in mind, guys, that all of these numbers right here are our z values. Okay, and all of these guys are evenly spaced parallel lines. So, what we can gather here is we can figure out what our n and our m are just by looking at this 2D picture. Okay, so the first thing I notice a nice point right here on the origin. That's going to be useful later. That's the point x equals 0, y equals 0, and z equals 0. Alright, so that's a point on this this linear function. Now, how can I find the slope in the x direction? Well, the slope in the x direction, m, is going to be the change in z over the change in x. Okay, so let's see what happens when I start at x equals 0 and I move over 2 units. So I moved 2 in the x direction. Where did I land in z? Okay, so the change in x, I did 0 minus 2, so I went from x equals 0 to x equals 2, and the corresponding z, I went from z equals 0 to z equals 6, right, because I'm on the line where z equals 6. Alright, so putting this together, we have negative 6 over negative 2 is equal to positive 3. So my m is going to be positive 3. And we can do the same kind of thing for n. So n is going to be the change in z over the change in y. So let's see where a good y point would be. Well, if I start at y equals 0, I can actually hop up 1, 2, and end right here at z equals 2. So I started at z equals 0, and I went up to z equals 2. And I'm dividing that by starting from y equals 0, and I actually moved up to y equals 2 as well. So this is the y equals 2, and then the line that I'm on right here corresponds to this z. So that's why we landed on 2 for both of those. Now simplifying this, we just get a positive 1, so n is equal to positive 1. And what is c? Well, c we can find using this point right here, this m, and this n. So our basic equation is z equals mx plus ny plus c. Subbing x, y, and z equals 0, I get 0 equals 0 plus 0 plus c, and so c is equal to 0. Excellent. So our final answer is z equals mx plus n times y plus 0, and that is our equation.